Yes, hello students and welcome for our online classes. This is our 18th lesson. Today, still under the topic of thermochemistry, we're going to deal with bond energies. We're going to deal with bond energies. So at the end of this class, you should be able to calculate the enthalpy change for different reactions using what is called bond energies. So our discussion will be based on bond energies. That is what we are going to learn today. Now, bond energies can be used to calculate the enthalpy change or heat of reactions. We have different chemical reactions, and sometimes you can be required to calculate the heat change for different reactions. In that case, in case we are given bond energies, then here we are going to look at how to use the bond energies to calculate the heat change that occurs when given reactions occur. So the standard enthalpy or the standard heat of reaction is actually the molar standard enthalpy of a reaction that involves change of products, change of reactants into products. So we are talking of heat change that occurs when reactants are converted into products. The heat change that occurs when reactants are converted into products. Now, chemical changes, chemical reactions normally involves reactants forming products. And for reactants to form products, there is, remember reactants, these are chemicals, and these chemicals are made up of chemical bonds. So one of the steps involved in chemical changes is the breaking of the existing bonds. So we have bond breaking, that is breaking of bonds. And after the bonds in the reactants have been broken, then in the products, new bonds are formed. So new bonds are normally formed. So bonds are broken, then the free atoms undergo rearrangement, and then new ones are formed. So for the reaction to take place, the bonds holding in the reactants must be broken so that new ones can be formed in the products. To illustrate this, to explain the process of the formation of products, let us consider AB reacting with XY to form AY, because A will combine with Y to form AY and XB. So let us consider this reaction. AB plus XY to form AY and XB. Now, the bonds present, so the bonds present in AB is AB. The bonds present in XY is XY bond. Then the bonds present in AY, and then we have XB. So the first thing that takes place is that we have bond breaking. So bond breaking means AB, the bond between A and B will break to form AB. The bond between XY will break so that we have the free atom of X and free atom of Y. So we have bonds breaking to form free atoms. That process is called atomization of the reactants. So the reactants will form free atoms. Now after that, the atoms will rearrange. There is the rearrangement of atoms, whereby A will combine with Y, and then a new bond is formed, AY. X will combine with B, and then a new bond is formed, XB. So we have new products, AY and XB. That is what happens during a chemical reactions. Bonds are broken and then new ones are formed as the atoms rearrange themselves. Now let us come to what is called bond energy, because that is where that is the main item here. So bond energy is the energy required to break one mole of a given type of bond. The amount of energy required to break one mole of a given type of bond. One mole of a given type of bond. So if you're talking of one mole of a given type of bond, let us say oxygen gas. The oxygen gas is made up of oxygen, oxygen, double bond. So oxygen, oxygen, double bond is a type of bond. When we write one molecule, this means one mole of oxygen gas. So this is one mole of oxygen, oxygen, double bond. We can say two molecules. So when we put two here, those are two moles of oxygen, oxygen, double bond. 2 moles of oxygen, oxygen, double bond. So the energy required to break 1 mole of a given type of bond is what we call bond energy. So in this list, in this table here, we have different bond energies, type of bonds, and the energy. Like hydrogen-hydrogen bond, the energy required is 431 kilojoules per mole. Carbon-carbon single bond is 436. Carbon-carbon double bond is 612. So these are bond energies. We are going to use them in our calculations. We are going to use them in our calculations. Now let's look at the first example. Our first example, we are told calculate the heat of reaction from the following reaction. Calculate the heat of reaction from the following reaction. So the reaction is hydrogen plus, we have hydrogen plus chlorine to give hydrogen chloride gas. The first thing is to identify the bonds present. So the bond present is hydrogen, hydrogen, plus chlorine, chlorine, single bond to give 2 hydrogen chloride. Then this side we have bonds broken. So the bonds broken here, we have one hydrogen bond, which is 1 times. So we come back to our hydrogen bond. Hydrogen bond is 431. Energy required is 431, which is 431. Then we have another one, chlorine bond, which is 1 times Chlorine is 239, 239. So this one we have 239. Let me get the total. Then on the other side we have bonds formation, bonds formed. So bonds formed. Here is 2 times hydrogen chloride. 2 times hydrogen chloride is 428. 428. So 2 times hydrogen chloride, which is 2 times 428. Then we add, so this side we have 431 plus 239. We have 670. 670. This is kilojoules. Then this side we'll have 428 times 2. We'll have 856 kilojoules. Now, when bonds are broken, energy is absorbed. So this one is endothermic. When bonds are formed, energy is released. This is exothermic. Now, delta H here, you simply take this, you bring this one down, 670, and then you bring this one, you put 856. So this one will be 670 minus 856. You get negative 186 kilojoules per, not per mole, kilojoules.